Good afternoon, students. We're talking about the Pythagorean theorem today, and our content objective is I will use models and diagrams and prior knowledge of right triangles to explain the Pythagorean theorem. And our language objective today is I will draw, label, and find missing lengths of right triangles by working problems in Go Math. Okay, so what we're going to do is start with the formula for Pythagorean theorem. We have a squared plus b squared equals c squared. Okay, and so a squared is going to represent the side, one of the sides or the legs of the right triangle, and then we have b is going to be the other leg, and then c is going to represent the hypotenuse of our right triangle. So let's get started by actually drawing the right triangle first. So you should have in your groups tray, the bins, you should have 4 rulers, one for each person. Go ahead and take that out. And I will pause while you get your materials. Thank you. Now you're back. So let's get started with drawing our right triangle. So I'm going to move down just a little bit on the paper so I can get a chance to make sure I have enough room for everything. So I'm going to do my first leg. Then I'm going to draw my second leg of my right triangle. And the last thing I'm going to do is connect the 2 legs and create my hypotenuse. Okay? So I have all 3 sides of my right triangle, and I'm going to put my right triangle symbol right here. And so from here to the left of my right triangle, that's going to be my leg A, and then to the right of my right triangle symbol, that's going to be my leg B, and diagonal or across from my right triangle symbol, that's going to be my C, or it's also known as the hypotenuse. Okay, excellent. So you should have all 3 sides of your right triangle labeled with leg A, leg B, and leg C. So I will pause for a moment. Okay, so now let's look at the relationship between my 2 legs and the hypotenuse. So if we look at the formula for the Pythagorean theorem, we see that we have a squared plus b squared equals c squared. In contrast, for our right triangle, we have a, b, and c. And so the squares is what the difference between the sides of my right triangle, and when we look at the square or the areas of the squares that come from the sides of the right triangle. So the next thing that I want to draw are the triangles, are the squares that are formed by the sides of the right triangle. And so we know that in class, if I write, you write. So while I'm drawing, you should be drawing. So now I have my first square. That's going to be my square B. Okay, so I have my leg B, which is going to be the leg or the side of my right triangle, which is congruent, and we learned that last week, which is congruent with this side of the square B. Next, we're going to look at, and we're going to draw the other side, and we're going to draw a square for the A leg of my right triangle. So as I draw, of course, like always, you should draw. So now we have our square A. And last but not least, then we have our hypotenuse. So now we're going to draw the square for the hypotenuse. And right now it may not be to scale. That means the actual length and size. But we're going to use this as our template. Kind of going across in our formula, but that's okay. we're just going to keep right on drawing. So I draw, you draw. May not seem like it's a square, but we are going to take it as a square, okay? So now we have our A, our square A, our square B, and last we have our square C, okay? So if I was to tell you that there is a relationship between the sides of a square and the side of the corresponding right triangle, then we can also say that this is represented with S for side. We can also say that it's a side on this square, and then there's also a side here. So my S, just as a note, S is equal to a side. Okay? So when we look at the leg, that is just the length of the leg. But when I look at the square as a whole, meaning my A square, then I need to know that area is equal to S squared. Okay? And that's the same thing with square B. So the area of square B is A equals S squared. And then for my square C, the area is equal to S squared. Okay, so I'm going to pause for just a moment. You can hit pause in order for you to catch up where we are, and then we're going to come back together and proceed. Okay, so if I was to look at my Pythagorean theorem, and I was to say that there is a relationship between this side of the square and the side of this right triangle, then I can say that A squared is equal to what? S squared. And then if I look at my B squared, I can also say that B squared is equal to this S squared, or side squared. And then last but not least, my C squared is equal to the S squared for the square C. Okay? So I'm going to give you lengths of the two legs for my right triangle, and then I want you to use the Pythagorean theorem to then find the length of our hypotenuse. Okay, so I'm going to say, and this should be, as I'm going through, this figure should look familiar, and it's familiar for those that actually did the homework or even looked at the homework from last night. Okay, so if I say that this side is 6 inches, and the side for square B, let's say it is, 8 inches. Okay, so if I have these two sides, and knowing that the sides of a square, all of them are equal, then if this side of this square is 8 inches, then what is the side, what is the length or the measure of this side of the right triangle? Exactly, it's also going to be 8 inches. So now let's look at using the Pythagorean theorem to find what is my measurement for my hypotenuse. So I'm going to use a separate sheet of paper to look at the formula for finding the length of the side of my hypotenuse. So I'm going to kind of switch over. Actually, I'll just add it to the bottom of here. Looks like I can kind of get it all on there pretty much. Okay, so we're going to use our formula: A squared plus B squared equals C squared. Actually, you know what? I think I want to backtrack just a little bit. Let's look at, we're going to keep this where our formula here, and I want to look at the area of this square. Okay, so if the side is 8 inches, I can look at this formula for the area of a square and figure out what the area of this square is. So I'm going to substitute the value of S, because we said that S is equal to the side, so S is equal to 8 inches for this square, so 8 squared, and then 8 squared equals 64. Okay, so the area of this square B is 64. Let's see what the area is for this square. So we see that the side is equal to 6 inches, so we have 6 squared is equal to 36. So the area for this square is 36 square inches, okay? It's 36 square inches, so I'm going to go ahead and note that, 36 square inches. I know it's kind of overloading on this side over here because the square is a little smaller, but we will proceed. Okay, so you can pause. If I've moved a little fast, you can kind of pause it and catch your breath, kind of look over your notes and make sure that we're on the same page. Okay, excellent. So now let's look at the Pythagorean theorem formula, and we're going to take the knowledge that we have as far as the measurements of the sides of square A and the measurements for the sides of square B to see if we can figure out or calculate what our C is, which is our hypotenuse. So for A, we look at our figure and we find that A is 6, and we keep our square for our formula, plus B, let's look, our side is, here it is, 8 inches, so we have 8 squared. Then we have equal. Do we know what C squared is? Exactly, no. So that's what we're solving for. So we're going to bring down C squared. Excellent. So now we can simplify this side of the equation. So we have 6 squared is 36, plus 8 squared is 64, equals C squared. Again, we don't know what it is, so we're going to just bring it down. Okay, so we further simplify this side. 36 plus 64 is 100, equals C squared. And now I need to, because I need C, which is our hypotenuse, but now I have C squared. So I need to do inverse operation of squaring C, which is taking the square root. So we take the square root of C squared, the square root of 100, and the 100 is a perfect square. So that means that the square root of this number is going to be a whole number. And so the square root of 100 is 10, equals the square root of C squared is just C. So now we found that our hypotenuse is 10 inches. Okay, so that means that now I know that my side, my hypotenuse for my right triangle is 10 inches. And now because I know the side of my square, I can now calculate what is the area for this square. So we know that the side is the same as our C length, so we know that it is also 10 inches. And now I can take the measurement, or the number 10, and substitute it into my formula, and I can get that the area for this square, square C, is 100 square inches. Now, isn't that just wonderful? And I know you're saying, oh, I got this. I want to try one on my own. But before we do that, go ahead and I'll pause, hit pause, and then we're going to look at 2 examples together, and then you're going to go to Go Math, and you're going to practice 2 on your own. Okay, here we go. So we have this right triangle, and we're going to, first thing that we're going to do when we see this right triangle, we want to label our 2 legs, which is A and B, and we also want to label our hypotenuse, which, if I didn't say it before, it's the longest side of the right triangle. So we're going to label our 2 legs, and we're going to start with this side is going to be our A, okay, and then for this side, this is our B, and the side that's across from or diagonal from the right triangle symbol is our C. And guess what? We don't know what the length is for our hypotenuse. Okay, so this is our leg. We have a leg over here. That's our leg A. And then up top we have our hypotenuse. Okay, so that's the most important step when you are trying to find the missing length in a right triangle is knowing what is your A, what is your B, and what is your C. So now that we have labeled our right triangle, we know what our A, B, and C are, so now we can use our Pythagorean theorem formula, so that's A squared plus B squared equals C squared. And each time you are finding the length, the missing length of a right triangle, I want you to write the Pythagorean theorem formula every single time. So now that we have our formula, we're going to substitute in the values of A, B, or C, and then we're going to solve for the one that's unknown. So for A, we find A, and A's length is 7 squared, plus our B, which is 24 inches, we have 24 squared, equals our C squared. We just leave it C squared because guess what? We don't know what C squared, what C is. Excellent. So now let's look at simplifying both sides of this equation. So we have for our first side, we have 7 squared is 49. For those of you that said, oh, I know what 7 squared is, but to square 200, to square 24, let's see how we're going to do that. So our famous and our faithful calculator. So we have 24 squared, and then you hit 24 and squared, and then enter. There we are. I had to do a little switcheroo. So 24 squared, and hit enter, and that gives us 5 plus 576 equals, again, C squared, because we don't know what that is. So now we simplify 49 plus 576, so we hit plus 49, and that equals 625 equals C squared. And again, we need C, not C squared. So the inverse of squaring C is taking the square root. So we're going to take the square root of both sides of our equation, and the square root of 625. If you don't know that, you hit the blue second key, the x squared key, enter 625, and guess what it gives us? 25 equals C. So now we know that our hypotenuse is 25 inches. Excellent. So I know you're ready to go, but there's one more example I want to show you. So let's look at our last example together. And again, the first thing that we want to do is we want to draw our right triangle. We want to label the lengths that they give us. And then next thing we're going to do is we're going to label our A, B, and C. So you can hit pause so you can get a chance to actually draw the triangle. Excellent job. I know you guys have taken care of that. So now we're going to label our A, our B, and our C. So this is a leg, A is a leg, and C is our hypotenuse. I know you got it. Excellent. So now we've labeled all sides of our right triangle. We're going to write down our Pythagorean theorem formula. A squared plus B squared equals C squared. So now we're going to look and find the values of A, B, and C. And then we're going to plug in what they give us. That means substitute in what they give us, and then we're going to solve for what they don't. So we look for A. A, we don't have a length that's given, so we're going to stay with A squared. And then we have plus B squared. B is, here it is, 12 squared equals our C squared. Excellent, we have a C, so that's going to be 15 squared. And please remember that the hypotenuse is diagonal from, is the side that's diagonal from the right triangle symbol. And let's write this on here just in case you didn't get it in the last. So the hypotenuse is the longest side. Okay, so we're almost there. So now we've substituted in the values of B and C, And so now we're going to solve for a. So we have a squared plus 12 squared is 144. 15 squared is, that's right, 225. And now we have a one variable equation, which is normally it's 2 steps, but it's going to be 3 steps because we have this square here. So we're going to use inverse operation, or we're going to add the inverse. So we have minus 144. And if we do it to one side of the equation, we must do the same thing to the other side. So now we have, this is pair of this, 0 pairs. 0 pairs equal how much? 0. Excellent. So now we're left with a squared equals 225 minus 144 leaves us 81. So we have a squared equals 81. But we don't want a squared, we want a. We just want the length of the side, not the area of the square. We may not see this square over here, but we need to remember that a squared equals 81 gives us the area of the square. So now we want to do the inverse of squaring a, which is taking the square root, and it's an equation still, so if we take the square root of one side, we have to do the exact same thing to the other. So the square root of a squared is a, the square root of 81 is 9, so we know that our leg A is 9, not inches, excuse me, centimeters. Excellent. So now we're going to label our right triangle, so 9 centimeters. Excellent. So now that we've looked at 3 examples, 1 from the homework, 2 new ones, now I want you to go to page 224, and you're going to work numbers 4 and 5 on your own. Go for it.